So today we're going to be looking at linear and quadratic models. So mathematical models, they allow us to represent the relationship between real-world quantities, analyze behavior, and predict future behavior. When modeling, we use three distinct types of models. So when we're talking about each model, it can be done using an equation, a graph, or a table of values. So with your given equation, you can create a table of values, you can create a graph of your data, and you can calculate the first differences, second differences, or a common ratio based on your graph. You would know which one to calculate. And we're going to go into what those first, second differences look like along with the common ratios. So starting with the linear model, our equation of a line is y equals mx plus b. So our m is our slope or our rate of change, and our b or y-intercept is the initial value. With linear models, the rate of change is always constant, going up or down by the same amount each time. So looking at the graphs here, this first one, we have speed and reaction distance. We notice as the speed goes up, the reaction distance also goes up. So because this line reading from left to right is going up, the slope is positive here. Next one, we have age and the maximum safe heart rate, and that's beats per minute. So looking at this, as age goes up, the maximum heart rate goes down. Okay, reading left to right, the line is going down, which gives us a negative slope. Okay, given the graphs, write an equation. Okay, these are both linear. We notice these both have a straight line, meaning we're in the form y equals mx plus b. Okay, so like we said, m is our slope or our rise over run. Our b is our y-intercept. So this first graph here, our b, where it starts, where it hits the y-axis, is at 200. So b equals 200. Our m, our slope, is rise over run. And we want to pick some nice points here that we can use. So we can use the point 2200. And another nice point is this one right here, which is 45 and 175. Okay, so the rise over run here, the rise, it's going down from 200 to 175. So that means it's going down 25. We'll put a minus 25. And then our run is how much it goes over to the right by. So going from 20 to 45, that's going over 25. Okay. Simplifying this, negative 25 divided by 25 gives us negative 1. So our equation is going to be y equals negative 1, or just negative x plus 200. Okay, if you want to have the 1 there as well, that is also correct. Looking at the next one here, we have the distance traveled. So our b, our y-intercept, where it starts, is at 0, 0 here. So our b is 0. And we can pick another point. We know that point is 0, 0. We can pick another point. This one's 160. So our slope, rise over run, we are going up 60 and over 1. 60 divided by 1 is 60. Okay, so our equation, y equals 60x plus 0, or we can just leave it as y equals 60x. Okay, so like we talked about on the previous slide, when the line's going down, we'll have a negative slope, so that makes sense with our -1 we found here. And when we have a positive line, one that's going up, it's positive slope, we notice that we have a positive 60 here, so that also makes sense. Okay, so we can also use a table of values to make an equation and to find our slope, or that rate of change. So we want to pay attention, we want to see what our x goes up by and what our y goes up by. Okay, so looking at the x's, those first differences, it's going to be -1 minus -2, which gives us 1, 0 minus -1 gives us 1, 1 minus 0 is 1, and 2 minus 1 gives us 1. Now looking at the y values, -1 minus -5 gives us 4, 3 minus -1 gives us 4, 7 minus 3 is 4, and 11 minus 7 is 4. Okay, so the thing that's going to tell us that our table of values is giving us a linear model is when our first differences, meaning these ones we found, are all the same number. So because these are all 4, we know this is linear. If these first differences were different numbers, we could not say that it's linear. It would be another option. Okay, so whenever you calculate your slope is going to be the rise over run, and the y value is your rise, the x value is the run. So our rise we found as 4, our run is 1. 4 divided by 1 is 4. Okay. And if we wanted to make an equation, our y-intercept is when our x value is 0. So when our x is 0, our y is 3, meaning our y-intercept is 3. So we can create an equation from there, y equals 4x plus 3. Okay, so that's looking at a linear model based on equations, graphs, and table of values. So we can also see what the difference is between a linear and quadratic model. So looking at this slide here, classify each of the following tables as linear, quadratic, or neither. So we want to look at our first differences. So 11 minus 15, -4. 7 minus 11 is -4, and 3 minus 7 is -4. Because all of these first differences are the same, then we can say this is linear. Looking at the next table, the first differences. -5 minus -9 gives us 4. 7 minus -5 gives us 12. And 27 minus 7 gives us 20. Okay, so we notice here our first differences are not the same, so that means this is not linear. Okay, so we can go on to look at the second differences. Now, if the second differences are the same, it is a quadratic. So that's doing 12 minus 4, and 20 minus 12 gives us 8. Because those are both 8, the second differences are the same, and we can say this is quadratic. Okay. So linear tables have the first differences the same, and quadratic tables have second differences the same. So if we calculate both first and second differences and the numbers don't match, that is when we say it's neither. Okay, classify each equation as linear, quadratic, or neither. So we know linear is in the form y equals mx plus b. Quadratic, or we're talking about parabolas, this is when we have a y equals x squared. Okay, so if we have an x squared in the equation, then we can say it's quadratic. If there are exponents higher than 2, we have higher than the x squared, that is when the equation is going to be neither. So looking at the first one, y equals x squared plus 7, the highest degree is the x squared. So because we have that x squared, this one's quadratic. Looking at the next one, y equals -5x plus 12. This is in the form y equals mx plus b, so this one is linear. Next one, y equals x cubed minus 2x squared plus 4x plus 7. Because we have an exponent higher than 2, we have that x cubed. This one will be neither. Okay. Next one is y equals 4 over x plus 2. So this has an x on the bottom. That is not one of our options, so this one is also neither. Next one, y equals -10x squared plus 4x plus 6. Because we have the x squared there, that's the highest exponent. This one is quadratic. And then we have y equals 8 minus x. So this is the same as saying y equals -x plus 8, which is in the form y equals mx plus b, so this one's linear. Okay, so for linear, it's y equals mx plus b, and this is when we have the exponent 1. Quadratic, y equals ax squared plus bx plus c, so having the exponent 2. Okay, so discussing certain properties of quadratic graphs. So when a quadratic is graphed, they produce a parabola. That is what we're calling it. Okay. When a is positive, the parabola opens up, and when a is negative, the parabola opens down. Okay, so when we talk about the a value, we have y equals ax squared plus bx plus c. So we focus on the number that is in front of the x squared, and that will determine whether it's opening up or opening down. Okay, so that first example is when a is positive, and the second one is when it's negative, that it will open down. So we want to now match each equation to a parabola. So we have option 1, 2, and 3. First, we can look at all of our a values. The first equation, there is an invisible 1 in front of the x squared. The second equation, so this is a is positive. The second one, we have a positive 3. So those graphs are going to have the parabola opening up. And then the third one, we have a negative 2 as our a, meaning it's going to open down. And these open up. Okay, so it's going to be easier for us to determine our equation 3. If we look at the 3 graphs here, only one of those is opening down, which matches with 3. So that's that one there. Now we need to figure out the difference between equations 1 and 2. Now, the other trick is that when we're given the equation y equals ax squared plus bx plus c, the c value is the y-intercept. Okay, so looking at our two equations, the y-intercept for the first equation is negative 3, and the y-intercept for the second equation is negative 24. So that's something that we can look at in our graphs. Looking at this first one here, we notice that where the y-axis is, the parabola is crossing at negative 24, which matches up with equation 2. And double checking so that one matches, we're looking where our y-intercept is. So on the y-axis, it's crossing at negative 3, and that's what we have here. So this graph is for equation 1. Okay. So you're going to be doing practice with linear and quadratic models. If you have any questions, please let me know.